Hello and welcome to the lecture Mathematical Preliminaries. Today we'll start the basic probability part 1. In this lecture we are going to define some definitions of probability. Then we define random variables, conditional probability and Bayes theorem. Then different aspects of discrete and continuous random variables, probability density function, cumulative distribution function, and we conclude with mean and variance. We start with a few definitions of probability. In probability, first we define what is meant by sample space. The sample space is the set of all possible outcomes of a random experiment. It is denoted by S or omega. For example, if we toss a coin, the possible outcomes either head or tail. So the sample space is each head and tail. For another example, for a rolling die, possible outcomes 1, 2, 3, 4, 5, 6. So the sample space is this. So this is called the sample space. Next, what do you mean by a probability of an event? The probability of an event is the measure of the chance that the event will occur. How probable that event to be occurred. So it is denoted by P. And if all outcomes in the sample space are equally likely, then this P is basically number of favorable outcomes and by divided by total number of possible outcomes. For example, for a fair die or a fair coin, the probability of head is 1 by 2. For a fair die, probability of k is 1 by 6, where k will be any possible size. So this is the probability. Now, what do we mean by a probability and random variable? Here, another definition. It's called frequentist definition. Given an event A, probability P of A by repeated conducting a relevant experiment, number of times A occurs, that means has okay, among total number of experiment, number is omega. So probability is basically number of A by number, total number of experiment. Now there is a very important definition. What do you mean by a random variable? A random variable is a function that assigns a real number to each outcome in the sample space of a random experiment. It is usually denoted by a capital letters x, y, or z. So basically, a random variable is basically a mapper that assigns a real number to each outcome in the sample space. For example, when a coin tossed twice, the sample space is maybe both are head, one tail, first tail, second head, and both are tails. So if x be the number of heads obtained, then this is a random variable. So hh is equal to x of ht is equal to 1 because x of th is also 1 and x of tt is 0. So the random variable x can take the values 0, 1, 2. So one thing you have to understand, random variable itself is not a probability. It can take any values. But a probability is generally associated with this, which can take a value between 0 and 1. That will come in the next phase. So what are the different rules, probability rules is this? First of addition rule, union of two events. In probability, the addition rule is used to find the probability that at least one of the two events occurs. So P A union B is PA plus PB minus P intersection B. Where P of A is probability of event A, P of B is probability of event B, and P intersection B is probability that both A and B occur. Now, if this A and B, event A and B are mutually exclusive, That means A and B cannot happen at the same time. Then A union B is PA plus B. So this is the addition rule. Next is the independent events. When two events are independent, when you can say that independent events are these events where occurrence of one event doesn't affect the probability of the other event. So if there is a coin and there is a die, you toss a coin and roll a die. These two events are not dependent to each other. So you can say these two are independent events. Similarly here, if A intersection B, basically if A and B are independent, then we can write a PA B. Okay, this is also called multiplication rule for two independent events. Okay, so this is next come another very important concept that is called conditional probability. In conditional probability is the probability of an event occurring given that another event has already been occurred. This conditional probability of an event B, assuming that event A has happened, is denoted by P, give B probability of P given A. That event A has already occurred. Knowing this, what is the probability of B to be occurred? So it is defined by P given A, that P of A intersection B by P of A, provided P of A. For example, when a fair dice is tossed, the conditional probability of getting 1, given that an odd number has been obtained, is equal to 1 by 3 at x. Now, you can understand the sample space is this 1, 2, 3, 4, 5, 6. And what is the odd number? A is 1, 3, 5. So that odd number is obtained given that. So A is given and B is 1. So B of B given A, that is number of A is equal to 3, number of A intersection B equal to 1, so is 1 by 3. Now as per your given definition, if you see that probability of B given A is basically A intersection B by PA, that is 1 by 6, definitely, because this is 1 and this is sample space 6. And what is A? Odd numbers 1 by 2. So we can some similar result in the both the cases. So this is the condition. So rewriting the definition of the conditional probability, we get A intersection B, P of A multiply P of B given A. This is sometimes referred to as product theorem, and that is important. It will come later. Next, what do you mean by independent events? That is also very important. A set of events is said to be independent if the occurrence of any one of them does not depend on the occurrence of or non-occurrence of the others. So the events are independent to each other. Let's say take an example. When two events A and B are independent, it is obvious from the definition P of B given A is equal to B, because A has no effect on it. If the events A and B are independent, the product theorem takes the form A intersection B is A PA into B. Conversely, if A intersection B PA or PB, the events A and B are said to be independent or pairwise independent. Now, this product theorem can be extended to any number of independent events. That may be number of n, any number, or n independent events, P of A1 intersection A2 intersection AN. This is P of A1 multiply P of A2 dot dot multiply P. When this condition is satisfied, then events A1, A2 or dot AN are also said to be total. So this is very important concept that frequently visit in this our lectures, that two events are independent. Okay. Now we are going to discuss one of the most important and frequently visited theorem called Bayes theorem. If B1, B2, Bn be a set of exhaustive and mutually exclusive events associated with a random experiment, and A is another event associated with or caused by Bi, then can be, as per Bayes theorem, we can say B of P probability of Bi given A is equal to P of Bi multiply P of A given Bi by summation 1 to n of P of Bi multiply P of A given Bi, where I is equal to 1 to n. So this proof is also very easy, because that we know from the condition probability definition, P of Bi given A of P of A section Bi by Pa, and from total probability theorem P of A equal to 1 to n, P of Bi multiply P of A given Bi. So then by using this multiplication rule, we can easily understand P of Bi intersection A is equal to P of Bi into P of A given Bi. So we can put it there, A of Bi, and we can find P of Bi A is equal to P of Bi to P of A of Bi P by A. And if we put this formula of P of A, it is P of Bi multiply P of A given Bi by summation 1 to n P of Bi probability of Bi multiply probability of A given Bi, and that is our base. So it's very easy to prove. Now there is one application of Bayes theorem, how problem can be solved for your understanding. A person takes a lab test for gluten allergy and the result comes positive. So this is the problem actually. Given the result is positive, we have to calculate the probability that the person has the gluten allergy and the probability that the person doesn't have the gluten allergy. Now we have the following data, the probabilities. Using the Bayes theorem, we can calculate the above probabilities. The test returns a correct positive result in only 98% of the cases in which the allergy is actually present, and the correct negative result is only 97% of the cases in which the allergy is not present. So furthermore, 0.8% of the entire population have this allergy. So what is the probability of allergic? Is very less, 0.8%, that means 0.008. So what is the positive allergy, correct positive result? It is 0.98%, 98%. That is positive given not allergy. It's 0.3% because that it is been given. And P of not allergic is 0.9%. Okay, because of this percentage P of allergic. So 1 minus 0.008 is 0.992. P of negative given allergy is 0.02. So then if we use a P of negative given not allergy is 0.97. Now if we have to, what is basically we are trying to find out that this probability, that a probability of allergic, that positive result has come, If given the result positive, we have to calculate the probability the person has the total energy. So first is, if we put these values, we can tell at 0.00784, that is the chance probability that person has the allergy, and it is non-allergic, even it is a come positive, it's basically 0.0297. So this is the way the Bayes theorem can be used to find out different probabilities when something is occurred. Now, the Bayes theorem is, we look it in bit different way. Okay. So as a whole, very simplistically, we say P of A given B is equal to P of B given A into PA by P. Now, this has a different meaning mostly in the predictions or if it's used in the machine learning. Now, this P of A, that is called the prior probability. What does this mean? The prior probability of event A, denoted by probability of A, is the probability of A occurring before knowing. That is very important to note, that probability of A occurring before knowing whether event B has occurred or not. So that's why it's a priori. Here A is treated as a proposition or hypothesis, and B represents evidence that may later be used to update the probability. So this is called a prior probability. Next comes probability of B. That is the evidential probability. The probability of P of is the evidential event of B. So P of A given B, that is called posterior probability. That we already been given. What is the probability of A? The probability of proposition or hypothesis A post the occurrence of the evidence event B. And what is the likelihood? That is P B given A. That how likely the evidence B is given that the proposition A has. So these are the major things that we will use later in our course. Okay, so these are the when we see that some Bayesian statistics or some sort of different machine learning methods, these kind of statistics meanings or tools use. Now next come probability and random variables. There are two types of random variables. One is discrete random variables, one is continuous random variables. In case of discrete random variable, it takes a finite or countable number of values. See the number of heads obtained when the tossing three coins. Whereas in the continuous random variable, it takes any value within a given interval. For that, it's the height or weight of the person, for example. Now, start with a discrete random variable. If x is a random variable, which can take a finite number or countably infinite number of values, x is called discrete random variable, as you said. When a random variable is discrete, the possible values x can be assumed as x1, x2 up to xn. Here in this table what we can see. The probability function for this discrete random variable, if x is a discrete random variable which can take the values x1, x2, x3 dot such that P of capital X is equal to x of I smaller is equal to Pi. Then Pi is called the probability function or probability mass function or the point probability function, provided P is I is equal to, we satisfy the following condition. The first condition is that Pi greater than equal to 0 for all I and summation of Pi. These are very simple and the basis of the probability. We are not just to mention for refreshing. The collection of the pairs xi and pi, I is 1, 2, 3 is the probability distribution of the random variable x, which can be represented in the table as given. So this is this probability distribution of a discrete random variable can be represented as a table. Next, the continuous random variable. and the probability density function. If x is a random variable which can take all values, either infinite number of values in an interval, then x is called a continuous random variable. For example, the temperature at a place, height of a person, lifetime of electronic device, so and so. So probability density function, which is defined as follows: if x is a continuous random variable such that p of x minus half of dx less than or equal to capital X less than or equal to x plus dx, then f is f of x. Then f of x is called the probability density function, shortly denoted as PDF, or popularly known as PDF x, provided fx satisfies the following conditions: that f of x gets equal to 0 for all x belongs to odd x, the real numbers, and the integral in the range of odd x of fx is equal to 1. So this is called the probability density function. Now, this probability density function we can understand more concretely by giving a range. Moreover, this if x belongs to the range between a and b, or p is equal to a or b, this is inclusive and exclusive a and b, is defined as p of a greater than or equal to x greater than or equal to b is equal to the integration a to b f of x dx. The geometrical interpretation is like this. This portion is called the probability density of this distribution within the range a and b. The curve y is equal to f is called the probability curve of the random variable x. Next comes the cumulative distribution function, the CDF. If x is a random variable or discrete or continuous, then p where x less than or equal to small x is called the cumulative distribution function of x, or a distribution function x and denoted by f of x. If f is discrete, f of x is equal to summation of g p of g, where x is less than or equal to x, and if x is continuous, fx is equal to p of minus infinity less than till x minus x is equal to minus infinity to x. This is the standard definition. Now, some useful PDF in machine learning. Probability density function of some continuous unknown variables which are frequent ML application as follows. First, of uniform distribution. As we all know that if the PDF is a continuous unknown variable 1 by b minus a within a range, and a is a constant, x belongs to in between the a and b, x follows the uniform distribution or the rectangular distribution. Most importantly, it's a Gaussian distribution or a normal distribution. If the PDF is a continuous random variable x, f of x is 1 by this sigma root over of 2 of pi e to the power x minus mu whole square by 2 of sigma square, where x belongs to minus infinity to plus. Then x is said to follow a normal distribution or Gaussian distribution. It's a very popular expression for us because from school days we know this distribution with parameters mu, and this sigma is the standard deviation of the distribution, also denoted as this normal distribution mu and sigma. Now, in this curve you can see the Gaussian distribution, it is values of sigma. The standard deviation determines the width of the distribution. You can say if it is a small, so it is a kind of strip, and it is a kind of width is high, its lambda is increasing. So this is the PDF of Gaussian distribution. Next come the mean and variance. X is a discrete random variable with probability mass function at p is equal to x is equal to xi and is equal to pi, and for I is equal to 1 to 3 and total. Then the mathematical expression of x at the arithmetic mean of x denoted by e of x is called expectation of x, said that mu is equal to e of x equal to summation I and xi pi. If x is a continuous random variable with a probability density function f of x, its expectation is basically defined as integration of Rx x fx dx, where Rx is the range space of the x. And what is variance? Variance is basically measure how far the values of the random variables are spread around the mean, how far it is from the mean. A larger variance indicates the greater variability. So what of x is expectation, x minus mean. So the random variable, how it distance, and take a square for this variable distance. So this is basically the variance. Now for a discrete random variable, variance of x is basically defined as this xi minus mu square into probability of x squared xi. Or for continuous random variable, it is minus into plus into x minus mu whole square for x. So it is very easy to understand. The mean measures the average value of random variable, where variance measures the spread of the values around the mean. A higher variance indicates a greater dispersion, while a lower variance indicates that values are closer to the mean. So that is the basic implications of mean and variance. So in this lecture, what we have covered, we first definition of some probability important terms, then we discuss what we mean by random variables, conditional random variables and Bayes theorem, and discrete and continuous random variables. Then we define probability density function, cumulative distribution function, and we then conclude by discussing mean and variance. In the next class, we'll continue this lecture for this basic probability.